We are being asked to find the derivative of this equation, and to do this we're going to need to do our quotient rule, which is going to be low d high minus high d low over low low. And in this situation this is going to be low, our denominator is going to be low, and our numerator is going to be high. So we're just going to go ahead and place cosecant x over 3 for our low in the numerator. And now we're going to have to find our high, the derivative for our high. So we're going to do ln 3 because the 3's derivative is going to need the ln as it has an exponent. But we're going to have to remember to carry this entirety over 2. Include it. So this is going to be 3, 1 minus 4x to the 2. And then we're going to have to find the derivative for the exponent, which 1 to 0 is just going to be 0, but 4 to the 4x2 is going to be 2 times 4 equals 8, which is going to replace the 4, and then 2 minus 1 equals 1, so this is going to be negative 8, because we have to remember the minus x. We're going to write that down over here. This is going to be ln 3 elevated to the 1 minus 4x squared times negative 8x. We're done with the first part of this. Now we're just going to put the high, which is going to be 3, 1 minus 4x squared. And now we need to find the low for the derivative for our low. We know that the derivative for the cosecant is going to be negative cosecant x, and then it's also going to be cotangent x. So we're going to want to put that over here, but we're going to replace the x's for the x over 3. Negative cosecant x over 3 cotangent x over 3. But we have to remember we also need to find the derivative for x to the 3. X to the 3 is going to equal 1 over 3 because x1, 1 times 1 equals 1. That's going to replace the 1 in front of the x, and then x1 minus 0 is going to be x to the 0, which equals 0. So it's just going to be times 1 to the 3rd. And then we have to remember the low, which is going to be cosecant x to the 3rd squared. For our next problem, we're also going to find the derivative. But to do so, we need to use the product rule, which is going to be u prime v plus v prime u. And in this case, our first term is going to be u, and our second term is going to be v. We want to find the derivative of u. Our derivative for ln is going to be 1 over x. This is going to be our square root over x, so it would look like 1 over square root x. We're also going to find the derivative of our square root x, which would be 1 over 2 x elevated to the 1 over 2 minus 1 over 2x negative 1 over 2. And our derivative would be a fraction because of the negative. And it would still be a square root because of the fractions here. So it would look like this. 1 over 2 x. And then we're going to carry along the tangent, our second term, per the product rule. Tan negative 1 sine x. And now we need to find the derivative for our v, our second term, which is going to be 1, because it's an inverse, our tangent is going to be 1 over 1 plus x2, but our x is sine to the sine x, so our derivative for that is going to be 1 over 1 plus sine x. But we also have to remember we want to find the derivative for sine x, which would just be cosecant x. We would add that over here. And we're also going to add our ln per the product rule. ln